In the modern world, warfare is no longer defined only by soldiers, tanks, or fighter jets. Technology has become the most powerful weapon in global conflicts. The nature of war is changing rapidly, and military experts around the world are closely studying this transformation. In the past, wars were decided by manpower and direct battlefield confrontation. Today, strategy, engineering, artificial intelligence, and economic sustainability are playing a much bigger role. One of the most important regions where this new type of conflict is being observed is the Middle East. Tensions between Iran, Israel, and the United States have created a complex geopolitical situation. These tensions are not only political, but also technological and military in nature. Iran has developed a defense strategy that focuses heavily on cost-effective mass production of weapons. Instead of relying on extremely expensive advanced military platforms, Iran has invested in producing large numbers of drones and missiles. The main objective is not necessarily precision destruction alone. The goal is to overwhelm enemy defense systems through numerical superiority. Military analysts call this strategy saturation warfare. In saturation warfare, the attacker launches a large number of weapons simultaneously. The defending side must intercept each incoming object. However, interception technology is usually very expensive. Modern missile defense systems often use radar tracking combined with interceptor missile launch mechanisms. Some interceptor missiles can cost millions of dollars per unit. If an attacking drone costs only tens of thousands of dollars to manufacture, a financial imbalance appears on the battlefield. This economic imbalance is becoming one of the most important factors in modern warfare. Defense planners are now forced to think not only about firepower, but also about long-term operational cost sustainability. Iran's drone development program gained global attention over the past decade. Despite facing long-term international sanctions, the country invested heavily in domestic scientific research. Local engineers and military researchers played a crucial role in technological development. International technology access was limited, which forced Iran to focus on indigenous production. The result was the emergence of mass-produced unmanned aerial systems. One of the most discussed drone models is the Shahed series. The Shahed drone family is relatively simple in structural design, but highly effective in operational deployment. These drones are often described as kamikaze-style attack platforms. The drone carries explosive payloads and flies directly towards the target. Unlike traditional fighter aircraft, these drones do not require pilot presence. This reduces operational risk and manpower requirements. The Shahed drone can travel long distances while maintaining relatively low altitude flight. Large group deployment is a common tactical strategy. Multiple drones are launched simultaneously to confuse air defense systems. Even if most drones are intercepted, the economic cost of defense interception becomes extremely high. This is why many military strategists are studying drone swarm warfare. The concept of swarm warfare involves coordinated deployment of multiple autonomous or semi-autonomous weapons. Artificial intelligence is expected to play a major role in future military control systems. Global defense organizations are investing billions of dollars in autonomous combat research. Another major development in modern warfare is hypersonic missile technology. Hypersonic vessels can travel at speeds exceeding 5 times the speed of sound. At such high velocity, detection and interception become extremely difficult. Several global powers, including the United States, China, and Russia, are competing in hypersonic research. The future battlefield may look completely different from historical wars. Instead of large army formations, combat may involve drone swarms, cyber operations, and electronic warfare. Military experts believe that algorithm-based decision systems will play an important role in future conflicts. Here on Kareem Historical Stories, we explore these complex historical and technological transformations, because understanding the evolution of warfare is essential for understanding global security. The modern battlefield is no longer defined by traditional armies alone. Instead, technology, economics, and intelligence now play a decisive role in determining the outcome of conflicts. Over the past several decades, many nations have shifted their military strategy toward developing low-cost but highly effective weapon systems. Iran's military development is one of the most discussed examples of this new generation warfare. Despite facing decades of international sanctions, the country has managed to build a domestic defense industry capable of producing ballistic missiles, drones, and underground storage facilities for strategic weapons. One of the key advantages Iran has pursued is sustainability in long-term conflict scenarios. Military experts now believe that future wars will not be decided in days, but may continue for weeks or even months. In such situations, economic endurance becomes as important as technological superiority. The concept of saturation attack strategy has gained attention in modern defense studies. In this strategy, the attacker does not focus on precision alone. Instead, the attacker launches a massive number of weapons simultaneously, forcing the defense system to react under pressure. Imagine a scenario where hundreds of drones are approaching a target from different directions. The defending side must intercept each threat individually. If the interceptor missiles are extremely expensive, the cost of defense becomes unsustainable. This is where low-cost drone technology changes the nature of warfare. Many modern kamikaze drones are designed using simple aerodynamic structures and commercially available components. These drones are not necessarily technologically superior in complexity, but they are strategically effective when deployed in large numbers. The psychological impact of such attacks is also significant. When air defense systems are forced to operate continuously, military personnel must maintain constant alertness. This creates operational fatigue and increases response uncertainty. Iran's drone program reportedly evolved through a combination of reverse engineering and domestic research. Over the years, several foreign technologies were studied, modified, and integrated into local manufacturing systems. Sanctions, which were intended to limit military development, ironically encouraged local innovation. Engineers inside the country were forced to develop independent supply chains for critical components. Fuel efficiency, lightweight composite materials, and simplified navigation systems became primary design goals. Another important factor in modern warfare is electronic warfare resistance. Many advanced drones are now designed to operate even in environments where GPS signals may be disrupted. This is achieved through inertial navigation systems and alternative guidance algorithms. Future warfare is expected to involve extensive use of artificial intelligence. Autonomous decision-making systems may allow drones to identify targets without continuous human control. However, this also raises ethical and strategic concerns among international organizations. Hypersonic missile technology is currently one of the most competitive research fields globally. These missiles can travel at extremely high speeds, reducing the reaction time available for defense systems. Several global powers, including the United States, China, and Russia, are competing in hypersonic research. The future battlefield may look completely different from historical wars. Instead of large army formations, combat may involve drone swarms, cyber operations, and electronic warfare. Military experts believe that algorithm-based decision systems will play an important role in future conflicts. Here on Korean Historical Stories, we explore these complex historical and technological transformations, because understanding the evolution of warfare is essential for understanding global security. The modern battlefield